Hi, 8th graders. Today you're going to be doing lesson 14, which is dealing with outliers. You're going to be investigating what outliers are, how to determine if something is an outlier, and then what to do about it. So your first activity in your book for lesson 14 is looking at a histogram and a box plot with healthcare spending. I would like you now to pause the video, take a couple minutes, and answer questions 1 and 2 on this page in your workbook. Go ahead. Okay, so you've tried answering these 2 questions. I did a little writing on the box plot here to try to get this idea of what is 1.5 times the IQR. And so I'm looking at my first quartile and my third quartile. I had to do some estimating because they're not falling exactly on the numbers here, so I estimated 2.1 and 4.9. That means my interquartile range is going to be 2.8, and 1.5 times the IQR just means that we're looking at the distance of the IQR, which is another 2.8, and then another half of that, which in this case would be 1.4. And if a data point is further away from your interquartile range than that 1.5, then we're looking at the possibility of it being an outlier. So statistically, we would call that an outlier. On this one, we don't know this exact value of this data point. It could be somewhere between 9 and 10, but pretty much everything between 9 and 10 is falling in that outlier range. So we would say that yes, there is an outlier. It's that last data point, might be 9.5. And yes, that one would be an outlier. All right, on the next thing in your workbook, you're going to be looking at page 100. And on this activity, if I was you guys, I would go ahead and use your standard deviation numbers file that we used last week to calculate standard deviation. And you can open that up and you can edit the numbers in there in order to answer those questions on page 100. So go ahead and do that. It's going to take you a little bit to enter the data. That's okay. And go ahead and answer those questions on page 100 and then come back to the video when you're done. All right, so you've been working on page 100. Here's what I did on mine. I entered my data just like we normally do, and then I added a few more calculations. So I calculated the IQR by taking the third quartile, subtracting off the first quartile. And then I added a box for 1.5 times the interquartile range, and I just added these formulas in. And then I added what would be a low outlier. So that would be your first quartile minus 1.5 times the IQR, because if you're thinking about it, this is your box plot, right? I could have an outlier this way, 1.5 times my IQR, or I could have an outlier going higher, 1.5 times my IQR. So this box, in that cell right there, I just took my first quartile minus 1.5 times the IQR, and then in the other one, for my high outlier, I did the third quartile and then added on 1.5 times the IQR. So now I'm looking to see if any of my data values would be an outlier. Well, my low outliers, according to my calculations, would be a negative number. That doesn't really make sense in this, and there are no negative numbers. But my higher outlier is anything above 8.79, because that's anything above the third quartile, plus 1.5 times my IQR. And the last number, which they did say represented the United States, does fall into that outlier range. And so we could consider that one an outlier. And again, it always says that you have to take into account the situation. I would say in this one, it would be safe to say that the United States is an outlier in their healthcare spending. Going back to your book, number 2, it says to remove the value for the United States from the data set and then basically see what happens to your standard deviation median, and interquartile range. So if we go back and do that, so I'm going to, I'll delete that too. Delete this. And then if I go back and look at my stats, my mean went down, which makes sense because you're taking away a high number. My standard deviation went down a decent amount. It was 1.9, and it went down to 1.5. That's a significant jump with this data because that standard deviation of 1.5 is kind of low to start with, or 1.9, excuse me. So going down to 1.5 is significant, and it just means that our data now has less variability, which makes sense because we took out a high outlier. My interquartile range is now smaller, again, less variability, and so my number now to be an outlier has fallen as well. So taking out an outlier will affect that data. It will affect your mean and your standard deviation because you're affecting the variability of the data. Okay. Now you're going ahead onto page 101 and go ahead and answer those questions there. There's also another question on page 102 that is part of this section. If you want to use your spreadsheet to help with your calculations, go ahead. And when you're done with this one, definitely try to find a partner and try to talk through how you work through this problem together. Go ahead. Okay, so you've tried out the origins of outliers activity on page 101, 102. In this first one, these last three data points should be considered outliers because I think when you figured it out as anything above like 568 or 572, somewhere around there, should be considered an outlier. Now, why do you think they might exist? Here's where you get to start thinking about, what does this data really mean? And it kind of brings in some gray area in statistics. But one thing that might come up is that, these were just 50 colleges in California. Some might be really big colleges, which means there might have more incidents of property crime. So it could be a possibility. I would think that yes, they should be included in the analysis of the data because if you're looking at 50 colleges in California, you might want to include the largest ones. So there's that one. Then on the next one, you were deciding whether to keep or remove the outliers. On the first one with Tyler rolling the number cube, the outlier there is 20, and yes, definitely remove that if you're analyzing this data because 20 is not a possibility when you're rolling a 6-sided die. In B, having 12 siblings would be considered an outlier. I would keep it, but before you keep it, you might just want to make sure that it wasn't a mistake, that someone didn't write down something wrong, or maybe the person didn't understand the question they were being asked, whatever it might be, but just make sure that that is an accurate data point. But if it is, keep it, because it's possible to have 12 siblings. And then the last one, the outlier should be 0. Again, I would keep it, but also make sure that the experiment was done correctly and that no mistakes were made. And if all of that is true, then yes, keep it, because their method for synthesizing biodiesel was not effective, apparently. So that's looking at outliers. And you are now going to work on the practice problems for lesson 14. I will stamp those when I get back on Thursday. And besides that, you also have Khan Academy homework to work on. So feel free to work on that if you have time. Have a great day, 8th graders. I'll see you on Thursday.